Another way for this one is to take the original problem, -4 equals y subtract 9, pick up the two pieces and swap them so that we write y subtract 9 equals -4. Then we'll proceed the same way we did before. Y subtract 9 equals -4. To get the y by itself, we realize the subtract 9 means add -9. To eliminate this -9 that is being added, we add its opposite. The opposite of -9 is 9. And so we add 9 to both sides of the equation. Y plus -9 plus positive 9 equals -4 plus positive 9. On the left, the 9 and -9 are opposites, so they in effect cancel, leaving y. On the right, -4 plus 9 is 5. And so our equation ends up reading y equals 5. Remember that this is simply another way to do the same problem. If you choose to switch sides, do so carefully. If you choose not to switch sides, realize that it's simply a matter of your choosing. It does not affect the answer. It affects only the order in which the problem is written as you work it. Now let's do another example. This time we're going to do one that involves fractions. Example 3 is -1/6 plus a is equal to 2/3. -1/6 plus a is equal to 2/3. This time the variable is on the left-hand side of the equals mark. The variable is a. A is not alone. A is not alone. A has an extra term with it. That term is -1/6. To eliminate -1/6, we'll add its opposite, which is +1/6. And so we'll add +1/6 to both sides of the equation. +1/6 plus -1/6 plus a is equal to 1/6 plus 2/3. As before, a number and its opposite add up to 0, and so they in effect cancel, leaving a alone on the left-hand side. On the right-hand side, we add 1/6 and 2/3. To add fractions, find a common denominator. The common denominator here will be 6. And so, on the left we have a. On the right we have 1/6 plus 2/3 converts to 4/6. 1/6 plus 4/6 is 5/6. And so our solution is a equals 5/6. For the check, we copy the original problem, which is -1/6 plus a equals 2/3. We make the T format. The number we're checking is 5/6. So we have -1/6 plus parentheses to receive the 5/6. On the right side of the wall, we have simply 2/3. Then, -1/6 plus 5/6 is 4/6. On the right, we simply copy 2/3. 4/6 has a common factor of 2 in the numerator and denominator. 4/6 reduces to 2/3, and the 2/3 equals 2/3 is true. That means that the solution a equals 5/6 can be safely indicated as the correct answer. Now I have another set of exercises for you to do. Copy these exercises, then stop the tape, work the exercises, and restart the tape to check your answers. Your 3 exercises are, with instructions, solve each equation. Exercise 1. M subtract 10 equals 7. M subtract 10 equals 7. Exercise 2. 9 equals -9 plus P. 9 equals -9 plus P. Exercise 3. -4/5 plus C equals 1/2. -4/5 plus C equals 1/2. Be sure you copy these accurately, then stop the tape, work the exercises, and restart the tape to check your answers. Your answers should be, for number 1, M equals 17. M equals 17. For number 2, P equals 18. P equals 18. And for number 3, C equals 13/10. C equals 13/10. If you made a mistake and cannot find your error, be sure to mark on your paper where you need to ask for help when you go to the lab. Now we're to our third and last objective on this tape. This is the last of this special rules, the multiplication property of equations. Multiplication property of equations. This says, multiplying the same non-zero number by both sides of an equation does not change its solution. Multiplying the same non-zero number by both sides of an equation does not change its solution. Multiplying the same non-zero number by both sides of an equation does not change its solution. Notice a peculiar word here, non-zero. Multiplying the same non-zero number. A number is non-zero if it does not equal 0. Think about what happens when you do multiply by 0. Multiplying by 0 gives us 0. If I take an equation, let's say the equation is A equals B, multiplying both sides by 0 would give me 0 times A equals 0 times B. 0 times A is 0. 0 times B is 0. I have a true equation, 0 equals 0, but I have not found a solution involving whatever the A variable might be or whatever the B variable might be. The equation got eliminated. I got down to nothing on both sides, to 0 on both sides. Multiplying by 0 doesn't give us a false answer. It just doesn't give us anything. And so when we multiply, we have to be sure we don't choose to multiply by 0. Let's take a look at uses for the multiplication property. This list of uses is lengthy, but it's terribly important. The multiplication property turns out to be one of our most valuable tools.